Hello, Algebra students. Welcome to our very first review video of the new school year. I'm very excited to discuss with you everything that we're going to see and need to know for your first mid-chapter quiz, and that is on Chapter 1. Now, as a reminder, you have notes, so many beautiful notes in your binders. So if you are using those to study, this test will include sections 1.1 through 1.4. All right. So with that being said, let's jump into some review of some of the big ideas we've learned in this chapter, because these are going to be the types of questions to expect come test day. So first is translations. Now, if we're doing translations, we are trying to take either a sentence written in word form and turn it into an algebraic expression with variables and numbers, or vice versa. So in these first examples, they're giving us a sentence. We need to turn it into an expression or equation. So the first thing I see is the product of. Now, when we see the product of, that's telling us that the next piece needs to be in parentheses, so that we show what we are finding the product of. Now, in this case, we're finding the product of 5 and the sum of a number x and 3. So the 5 can stay on the outside, actually. But what needs to go in the parentheses is what the 5 is being multiplied by. And I know that because it uses the equation, the sum of. So that means we need to find the sum first and then multiply it by 5 to get the product. So to make sure that's done in the correct order, we're going to write the sum of a number x and 3. So that's x plus 3. So now we have an expression that represents the product of 5, so that's the first factor in our product, and the sum of a number x and 3. So that means we need to combine x and 3 with addition before multiplying, because it didn't just say the product of 5 and a number. If that were the case, we'd be multiplying 5 times x. In this case, it said 5 and the sum of blah, blah, blah. So that's when we know we need to make sure we use the parentheses. So next, we have is. So this is our equal sign, and 12. So that's telling us what our equation equals. Whenever you see the word is, that's our equal sign. So now we've taken our sentence and we've turned it into a proper equation. Let's do some more. The next one, 27, so there's our first number, decreased by a number. So if we're decreasing 27 by an amount, we're taking that amount away from 27. So we would write this as 27 minus x. Now there was no is, so there's no equal sign. This is just an expression. Next up, we have 24 less than the product of. So here we go. This is another example where we have the blank of. So this is leading us to set up these two pieces first and multiply them before we do anything with the 24. So it's the product of 3 and m. So we can start with that. 3 and m, the product, that's multiplication. So I would write it just like this. And then they're saying that we're finding what 24 less than that product would be. So we're going to do 3m minus 24. If it says less than, that means the first number is the number you're taking away. So if I said 5 less than 7, I would be doing 7 minus 5. All right, next, let's translate some expressions and equations into word form. So we're going to start with this first one. Now I see 8a minus 4c. So in this case, I am going to write this out making sure to use all of my keywords and vocabulary to make sure that whoever's reading this translation uses the right equation and translates it properly. So I'm going to write this as, we can do 8a minus 4c, but that's not really using any of my vocabulary. So instead, I know that subtraction, which is happening here, is the difference of, and then the product describes the multiplication happening with these two. So we could write the product of 8 and a number A subtracted by the product of 4 and, here's the key, another number, because this is a different variable. So I want to make that clear, that the first variable is A, and then another number is represented by the different letter C. So that would get me full credit. Let's do another one so you can see some more examples, and if you need more after that, check your textbook or your notes. Now this time, we have a multi-step equation. So I'm going to just separate my page a little bit so I don't get too confused while I'm writing. And we're going to read this first to ourselves without writing anything. I have x plus 5 equals 2 times 7 plus x. So in this case, I am going to write the sum of x and 5. So there's this half of the equation. Then we have the other half. So the sum of x and 5 is 2 times the sum of 7 and x. Now, if I were to translate this back, the sum of x and 5, so that's first, and that would be x plus 5, is where our equals sign belongs. And then 2 times the sum of, this is the key word that tells me that these two pieces need to be in parentheses. Alrighty, let's do one more on this slide. Now this time, we have 4n equals x times 5 minus n. So I'm going to write this as the product of 4 and an unknown number n is another number, this time it's x, times the difference of 5 and n. All right, so there are my 3 translations. Let's keep rolling. We're going to work on literal equations. So the major key to remember here is our goal is to isolate the given variable. And we already have practiced this a lot because we're doing the same thing if we're solving a regular equation. Only this time, we don't have to actually do any calculations most of the time because we're just working with variables that represent various unknown numbers. So in this first example, we have 15x plus 1 equals y, and we want to solve for x. So before I start, I just want to find the x that I'm trying to isolate. And in this situation, it's right here. Now that I have found the variable that I'm trying to isolate, I'm going to see what else needs to move away from it to achieve that. And in this case, it's the 1 and the 15. So we've talked a lot about that third wheel. That means that plus 1 needs to be our first piece that we move to the other side. So I'm going to subtract 1. Now that will leave me with 15x on the left and y minus 1 on the right. I couldn't do anything else because we don't know what y is, so we can't do any subtraction. Now that we've done that, we're a step closer, but we still need x completely alone. So we're going to divide both sides by 15, and we end up with x equals y minus 1 over 15. And that's my final answer because I have now solved and rewritten this equation for x. Let's do another one. Here we have ax minus b equals c. You might be thinking, oh my gosh, this one has no numbers whatsoever. That's okay. We ain't got to worry about it because they want us to solve for x. So we do the same thing we did previously. We're going to find x. It's right here. So we have to move the a and the negative b. We're going to move that third wheel, that constant first. So to move the b, we're going to add it to both sides. And that's going to leave us with ax equals c plus b. Now they want us to solve for x, so we're almost there, but we want to separate the variable a from the variable x. So we're going to divide both sides by a, and we end up with x equals c plus b over a. All right, so let's keep doing some equations using these same strategies. Up next, we have literal equations again. This time, we're solving for y's. Our first expression, or equation, I should say, because it does have an equal sign. The y is right here. So we want to isolate that, but it's within parentheses. So I have to move everything away from it first before I can even break my way into those parentheses. So then I'm going to look and see what's happening here. Well, when I look a little bit closer, I see that this is really x times 1 plus y in parentheses equals z. So because this is being multiplied, x times the parentheses, if I want to get y alone, I can start by moving the x. And if we're multiplying the parentheses times x to isolate and eliminate that variable from this side, we're going to divide by x. So that's going to leave us with 1 plus y equals z over x. Now we're getting close, but they want y completely alone. So the last thing I have to do is get rid of the 1 that's in front of it. Now it's a positive 1. There are no other signs of operations happening, no multiplication, division, subtraction. So since this is a positive 1, we're going to subtract 1 from both sides, leaving us with y equals z over x minus 1. All right, one more. Let's now solve for y, but this time we have a longer equation. 7x plus 3y equals m. Y is right here, so I want to move the 7, the x, and the 3 away from it. Now, just like when we're solving equations, I don't want to separate or do anything with 3y until I've done any addition and subtraction I need to do to get it alone. So here, just like the last one, we have 7x. There's no sign in front of it, so that's a positive 7x. which means to move it, we're going to subtract 7x from both sides. And we end up with 3y equals m minus 7x. Now from here, we have one final step, and that will be to divide by 3. The last thing we need to do to get y completely alone. So our final answer is y equals m minus 7x over 3. So the important things to remember with our literal equations are things that you've already been practicing last year and this year. And that's inverse operations, identifying what the correct operation is, and knowing how to move the pieces of an equation back and forth across the equals sign. So hopefully that's feeling a little bit better, but please remember, if not, you can always come see me in the Math Center or shoot me an email for additional help. All right, so let's get into some word problem action. In this situation, Martin is proofreading articles for his local newspaper. He gets paid in 2 different ways. The first amount of money he earns is determined by $55 per the number of days he works. So in this case, I could write this, just this little section, as 55 times the number of days he works. But in addition to that, he also ends up getting $7.50 for each article he completes. Now, $7.50 for each article, I don't know how many articles he's doing every day. And he probably doesn't know that until it happens. Like, he probably can't predict. So we're going to use A equals articles. So we're using the variable A to represent the articles that he is proofreading. So now they want us to write an expression to determine how much Martin earns. So Martin's earnings is going to be equal to the $55 per day he's receiving. So $55 per day plus the $7.50 he's earning per article. So there is our expression. That will help us figure out the answer to part B. Part B asks us how much will Martin earn if he works for 3 days. So D is going to be replaced with the value 3. And he reads 12 articles. So A equals 12. Now, how much will he earn? We need to plug these numbers into our original expression. So the original expression that we wrote was M equals 55, and then we would replace D with the number of days that he's working, so that's times 3, plus the $7.50 for each article times the number of articles, and they told us he wrote 12 articles. Now that we've done that, we're going to use PEMDAS to simplify it. So PEMDAS tells me to multiply first. 55 times 3, that's going to give us 165, plus 7.5 times 12, 90. So Martin's total earnings for those 3 days would be 165 plus 90, $255. So he's made a pretty penny for reading 12 articles and marking them up. Not too shabby. All right, let's continue with that's the same word problem. Let's continue with some equations. Now, these first couple are some of the more challenging ones we did, which is solving equations with variables on both sides. So I'm starting with these because these seem to give us the most frustration in class. Now, I will say we were doing really good by the end of our last session. So this might start feeling easy peasy pretty quickly. When I'm solving, I'm going to start with the first one over here on the left. 3 times y minus 2 equals 6 times y minus 1 minus 3y. First thing I notice, I've got parentheses, 2 sets to be exact. So I want to eliminate those I want to get rid of the things I don't need. So the parentheses, we're going to get rid of by distributing. So this becomes 3y minus 6 equals 6y minus 6. And then we bring down negative 3y. Now from here, we have some like terms. These two happen to be on the same side of the equal sign. So before I start moving things from one side to the other across the equal sign, I first want to just combine like terms that are already on the same side. So on the left, we don't have any like terms that can be combined. We just have 3y minus 6. But on the right, we have 6y minus 3y. So that's a total of 3y minus 6. Now you might already be thinking, ooh, I think I know this answer, but we're going to check it just to be sure we're not jumping ahead of ourselves. Alrighty, so for the next part, we're going to finish solving and get y completely alone and by itself. So I'm going to subtract 3y from both sides. Now because the other 3y was also positive, that cancels both of them out and leaves us with negative 6 equals negative 6. Now this is where we talked about if it is a true statement, meaning yes, negative 6 is equal to negative 6. That's facts. When that happens, that's when we are going to label our answer as infinite solutions. Because that's telling us any value we plug in for x is going to work in this equation. So I have an infinite number of solutions because anything and everything I try will work. Alrighty, let's move on to the next one. Again, similar, a couple more steps though. So first thing I do is look over my whole problem just to kind of establish a game plan. When I look it over, I see parentheses, so let's start there. We're going to distribute both sets of parentheses. That will give me 5p plus 15 plus 9 equals 3p minus 6 plus 6. Now, let's look for some like terms. First thing I see, I have like terms here and here. I can combine those. 15 plus 9 is going to be 24. Then on the other side, we have negative 6 plus 6. Now if we combine those, negative 6 plus 6, that's going to give us 0. So all we're going to bring down is 3p. Now, we're doing pretty great, but we need p, all of the p's combined and then isolated. So since I already have 24 over here on the left, I'm going to subtract 5p from both sides. And the reason I'm subtracting and not dividing is because I'm not trying to separate the 5 from the p. I am just trying to move that entire group to the other side of the equation. So that becomes 24 equals 3p minus 5p is negative 2p. Now we're almost done, but p is not alone until we've divided by the coefficient. So we're going to divide both sides by negative 2, and if we need to, we're going to use our calculator to make sure we get the negative sign correct. So in this case, 24 divided by negative 2, that's going to give us negative 12 equals p. Now in this situation, that is a true statement, and it's our answer. They asked us to solve for p. P equals negative 12. Okay. We're going to go through a couple more. Feel free to pause this video at any time. Fast forward if you want to. Rewind and watch again. This is your video to use how you see fit. So I'm going to go through some more examples just so we see a little bit of everything that could possibly show up on the test. So for this first one, n over 10 plus 3 equals 4. Whenever I have a problem like this, n divided by 10, that's one group. 3, that's a constant. It's by itself. So first thing we're going to do is move the 3 to the other side. That gives me n over 10 equals 1. Now, We're not done until n is by itself, so I'm going to read this back to myself with the operations named. N divided by 10. Saying that helps it become more clear that to get rid of that denominator or that divisor, I'm going to multiply both sides by 10. And that will give me n equals 10. All right, now this next one, you will see one like this probably, because it's important for us to understand what all is happening when we have 2/3 times y equals -8. Now we want to get y alone, so we're going to have to move 2/3. A lot of times students want to subtract. However, we can't make that decision until we see what is keeping them together. And in this case, multiplication is keeping them together. So we would want to divide both sides by 2/3. So that would end up being -8 divided by 2/3. And we learned keep, change, flip. If we're dividing by a fraction, we keep the first number, change division to multiplication, and turn this to 3/2. So when we've practiced that a lot, this times the reciprocal, times the flipped part of that process. That's going to cancel out and leave just the y. Then we do the same thing on the other side with the -8. -8 times 3/2. So -8 times 3, that's going to be 24, but negative, because negative times a positive is a negative. And then 1 times 2 is 2. So y equals -12. That would be our final answer. Now the last one on this page is going to be 4n minus 8 equals 3n plus 2. So you can do a couple things. You can move your variables first or your constants. It's your preference, and as long as you're following the rules of the order of operations, we'll all get the same result anyways. So here, I've decided I want to add first. I'm going to add plus 8. Now, like I said, you might have chosen to do -3 first. That's okay. But when we add our constant, we end up with 4n equals 3n plus 10. Now, we need to get all the n's collected onto one side. Right now, they're split up. So we'll subtract 3n from both sides, and that just leaves us with n equals 10. So our final answer is n equals 10. All right, guys, so that's the end of our review. I just want to wish you all good luck on your preparations. And I want to remind you to please ask any questions that might still feel funny, all right? I'm here to help you prepare, but I can't read your mind. So if you're having some trouble, let me know somehow. Shoot me an email, find me in the hallways at school, stop by my room, or even have your parents call if you need to. But I promise I'm not too scary, so I would really love for you to come talk to me if you need anything at all to do well on this upcoming test. Thank you guys so much for joining me in our first review video of the year. I hope you have found it helpful, and I